right? So what I can do is say I will host my search web service, my booking web service, and allow the external websites to communicate using HTTP SOAP, whereas my customer care and my backend operation, I'll ask my dev team to create a remoting a remoting search server as well as a remoting booking server, so that my travel website, my customer care, my backend operations all make use of .NET. So there is no question of interoperability in between them. So I don't need to communicate with my web service using HTTP SOAP and get comparatively bad performance. So rather, I can go for a remoting search server which replicates most of the search web service, and remoting booking server which replicates the booking service. So I just need to host this thing, and my customer care will use NetTCP protocol to communicate with this, and again the same with booking service and the same with backend operation. So these guys will perform much faster than these guys who work using HTTP SOAP. So I had a lot of performance gain, which is very important in case of highly in terms of application which has a large amount of transactions involved. So I attained my performance gain taking advantage of these applications being in the same server. But the problem here is this performance gain which I achieved comes with a cost. What is the cost? The cost is that it's not necessary that since you have a search web service, you can easily replicate it to the remoting server. The environment needs to be different, the skill set needs to be different. So, two things: either my development team is going to take more time to come up with the remoting application, and then set up the environment, then host it and connect it to the client application. Or it could also be possible that the guys who has created the search web service for me does not have enough skills to work with the remoting application. Then I'll have to fund to get another set of skilled people to come up, to be on board, learn the business, and then come up with a remoting application and then deploy it and make sure it's working. So it's going to take much time, as well as I'm going to end up spending much money. So this the third option will be a message queuing mechanism. Again, same as remoting, it's going to take time, money, and different and people with a different skill set. So these were the options we had with all the remoting mechanisms which were available before WCF. Now let's see how things change with WCF. So with WCF, as I said, again the it's not going to be a search web service. It's a search WCF service. Please bear with me. Just keep in mind that this is not going to be a web service anymore with WCF. So I have a travel website, and I have a search WCF service, and I have a booking service which is also WCF. Say this service I host it in IIS. So if you see, the travel website communicates with the web service using HTTP SOAP, and the external websites also, because of interoperability, communicates with HTTP SOAP. But if you see the customer care application and backend operations which are in my same network, they don't need to communicate with these services using HTTP SOAP anymore. They can communicate with NetTCP to this search web service, to booking web service, because as I said earlier, WCF allows uh, supporting multiple protocols at the same time. So I host the application IS. Uh, uh, I want to be very specific about this. When I say I host the application IS, it's going to be IS 7 or above, because only that supports NetTCP protocol and things like that. If you are using IS 6, it will support only HTTP, not NetTCP. So I'm assuming that you guys, when you are following this tutorial, you guys are using the iOS 7 or above. In the hands-on, I'll try to make sure that I add tutorials for both iOS 7 and 6. So we'll see that later. But yeah, here the search web service, the search service is going to be a WCF service, and it supports NetTCP and HTTP SOAP. So I've configured my WCF services to support both NetTCP and HTTP. So well, external guys with interoperability issues can communicate with my web service using HTTP SOAP, and my internal applications, which are native .NET applications, and which resides in the same network and which does not have any interoperability issues, can make use of NetTCP protocol, and hence take advantage of being in the same network and gain a lot of performance. And the second advantage is, the first one is that I gained a lot of performance. Second thing, I gain a lot of money and time. I save a lot of money and time, as here now I don't need to have a remoting server. I don't need to have a queuing server. All these purposes will be satisfied by the WCF service. The only thing is, I my dev team who created the WCF service will have to configure the endpoints in such a way that each and there will be multiple endpoints, and each endpoint will support multiple protocols, binding protocols, either say support HTTP, another endpoint which supports NetTCP, another endpoint which supports queuing, or maybe if there is another endpoint which supports some encoded binding or things like that. So I achieve all the things. Previously I have gone through two separate scenarios, one with without much performance, second thing with much performance but at the cost of having a remoting server or a queuing mechanism. And here with WCF I get everything as a single package, where my single service will serve to different clients with different protocols. With that, we'll go to WCF architecture. So as I said, I downloaded this from MSDN website. So here this is a WCF application. So on top we have activation and hosting, then we have the messaging layer, then we have the service runtime layer, and then we have the contracts. So if we go to as a client, as somebody who's learning WCF, the most important layers for us is going to be activation and hosting, and then we have contracts. So messaging and service runtime we'll see later when we do the hands-on. But otherwise, activation and hosting, as I said, a WCF service can be hosted in either IIS or EXE, or a Windows service, or a complex object. So here first, Windows activation service. So whoever does not know Windows activation service, just read it as IIS. So that means you can host your WCF service in IIS, then you can host your WCF service in a EXE, which is a WinForm or a console application, and then you can host in a Windows service or as a complex object. Then you have the messaging layer. That is where your messages are encrypted or decrypted. The security checkings are done, or the security mechanisms are added to your message, and things like that. Then we have the service runtime, where we'll take care of the behavior. So this also we'll see later. And on top of everything, we have contracts. So if you are learning WCF, contracts is the most important part of WCF. This is going to be the building blocks for a WCF service. So for a WCF service, the building blocks is going to be contracts, just like classes are for an object-oriented programming mechanism. So here we have data contract, then we have message contract, we have service contract, we have policy and binding. These are the contracts which are very significant in this layer, but we have many other contracts which we will see after some time. Um, the data contract, just for the sake of that, I'm just going through that. Data contract is going to be the classes which you use to transfer the data to and from a WCF service. A message contract is nothing but a message uh, within which you pass the response to a WCF service. And then the service contract is nothing but a service offered by a WCF service. So a service contract is a group of uh, methods exposed to the client from a WCF service. Then we have policy and binding, which is nothing but as I said, the multiple protocols which are being supported by the WCF service. Just skipping the WCF architecture, nothing much more in that. With that, we reach the basic concepts of WCF. Um, so the basic concepts of WCF is going to be address, binding, contract. Then we have behavior, channels, and metadata. So address is nothing but a URL you use to access a WCF service. So as I said, a WCF service can be hosted with an IS or with a Windows service or anywhere. But whatever it is, we should give up an open port in the server, so that we should allocate a port in the server so that the client can communicate with the server, and that will surely be through the name of the machine or whatever which we call a URL. So address is nothing but a URL which a client can use to access a WCF service. So after address we have binding. Binding is it's basically the various protocols which you can use to communicate with a WCF service. So as of now, we have basic HTTP binding, then we have WSHTTP binding, then we have NetTCP binding, and then we have custom binding. Basic HTTP binding is nothing but the HTTP SOAP based protocol which we used in the old web services world. Uh, Other than that, the WSHTP binding is the default binding which comes along with with WCF with WCF. So this contains a lot of you know built-in security mechanism and encoding mechanisms just to make sure that the transactions through to and from a WCF service is secure and reliable. Apart from that, we have the NetTCP binding, which is more or less like remoting. So here, if your application, the client and the server, if it's going to be in the same platform and there is no interoperability issues, then you can go for NetTCP binding, which will be much faster than WSHTP binding and basic HTTP binding. And apart from that, we have custom binding.